Hey everyone, in this video we're going to be looking at this very hopefully not too difficult to follow problem. Once you see it, it's not too difficult, but yeah. So we have a concave mirror, we have some given focus point in the radius of curvature, which is given to be 21 centimeters, and we have some point A. What we're asked is how far does point A have to be from the mirror such that the magnification of the image and the distance of the real inverted image is at infinity. So what does this really mean? Well, for the magnification to be at infinity, we know that magnification equals negative final distance over final initial distance. So magnification equals negative of the distance of the image over the initial distance of the real object itself from the mirror. So for this to be infinity, we know that the image must blow up to infinity, right? So when we look at the mirror itself, the image is just completely distorted. It might just look like one color and just blown up, like, or I should say, like real crazy. How far does it have to be to exhibit that behavior? Well, we must know that for magnification to go to infinity, that only happens if and only if this distance of the virtual image goes to infinity. And then d sub naught can be any real value other than 0, or I guess infinity in this case, because that would be kind of weird, infinity over infinity. But hopefully you can follow. That magnification needs to be infinity. And hopefully this formula is you have it somewhere in your notes. But now notice the formula that relates the distance from the mirror to the image itself. And it's given by this. 1 over the distance of the object with respect to the mirror equals 1 over the distance where the image resides equals 1 over the focus point F. Okay, notice that now we need to solve for this in terms of these two variables here, and we already know what distance final will be. That's going to be infinity. Now, what do you notice about 1 over infinity? Well, hopefully you notice that this will go to 0. And if not, if you can't follow that, just kind of remember this idea. If I have one cookie, which is the 1 in this case, and I want to divide it among infinite amount of friends, well, I know that 1 over infinity is going to be 0, right? Because if I try and divide one cookie in an infinite amount of ways such that my friends get an equal amount of cookie, well, there's not going to be a cookie left at that point. It's going to be 0. That's what this is saying here. And now the equation drops to this. 1 over that initial distance equals 1 over the final distance. So and what we're allowed to do now is bring these things to the numerator. You could think about it as multiplying this over, and you're going to get that d naught, the distance naught, equals the focus point. Okay, so now we need to understand that to bring this image to infinity, A needs to approach F such that we go so close that they're equal. Okay, that's what we're doing. And as this approaches, we're going to see the image begin to blow up. It's going to just grow until it goes to infinity, right? And probably in or maybe not in an exponential manner, but we'd expect the image to kind of go like that, and its magnification just blows up, right? As we humanly bring it close, right? Because we can't really bring it close on a linear scale, at least not, maybe with technology we could. So I'm just kind of yapping here. Let's just figure out and finish out this problem. How is d naught equal f? Well, it equals f, and we can find f here knowing that the radius of curvature equals 2 times f, so 2 of these distances put together is that. So f in this case is going to be r, 21 centimeters, over 2. Okay, so that's going to be 10.5 centimeters, if you can follow the math there. So d sub naught is going to be 10f, or the distance of that real object needs to be exactly at f, and that's the distance there. So that's exactly how far away from the mirror you would have to put that image, such that you would notice that the magnification goes to infinity. So yeah. Hopefully you guys enjoyed this. If you did, please drop a like, comment, and subscribe. And I hope that you have a wonderful day. Bye-bye.